Welcome to the third video of the 4.4, more on graphing, slopes, intercepts, and the like. So, last concept we're going to talk about is parallel and perpendicular. That's not too terribly hard for most people to understand. Now, two lines are parallel if they never intersect. That is, I guess, two lines are parallel if they never touch each other. And I think that's the notion that most people have. But in order for these to not touch each other, what that really means mathematically is they have to rise and run at the same rate. So as long as they rise and run at the same rate, one's not going to be tilted in a different direction than the other, and they're never going to intersect. So if they're rising and running at the same rate, what that really means is two lines are parallel if they have the same slope. And they have to have different y-intercepts. If they have the same slope and same y-intercept, then it's just the same line. They're touching everywhere, not nowhere. So, right here you'll notice it says the algebraic condition that must be satisfied for two lines to be parallel is they must have the same slope and different y-intercepts. Or they could be vertical with different x-intercepts. So you could have a vertical line here and a vertical line there, undefined and undefined, like that. Okay? So perpendicular is a little bit different. I think that people think that those meet, and they meet at 90-degree angles. Okay, so they meet at 90-degree angles. So really, there's a couple different ways that we can talk about that. Now, these meet at 90-degree angles, and notice, one of them has a negative slope and one of them has a positive slope. So the slopes are of opposite signs. And the other thing about these slopes is they're reciprocals of each other. So one could say is they are negative reciprocals of each other. So let's say this has a slope of 2/3. This line right here that's perpendicular to it would have to have slope negative 3/2. That is, they're of opposite signs and they're reciprocals of one another. Or you could have a vertical line and a horizontal line, and that's going to be working as well. So, okay. So when we get down to determining whether the lines are parallel or perpendicular, and that's what we kind of have for the rest of the time, we need to know what their slopes are, because if they have the same slope in different y-intercepts, they're parallel, and they're going to be perpendicular if their slopes are negative reciprocals. So identifying what the slope of the line is very important. So we'll kind of look at these. Now we're determining whether these lines are parallel or these lines are parallel. So here, that right there, m equals -4. So really, this line right here would have to have a slope -4 in order for them to be parallel. Now, in order to determine the slope of this line, we need to get it in the slope-intercept form. So I'm going to add 2y to both sides. I'm also going to add 5 to both sides so I can get my y over to the left and the numbers to the right. So here we have our 2y, 5's cancel, 2 y's cancel. We have 8 plus 5, 8x plus 5. Now to solve this for y, divide everything by 2. This right here is our slope. So 8 divided by 2 is 4. This slope is -4. This slope is +4. Well, if something's positive and negative, they're definitely not parallel, so the answer to this one would be no. A resounding no, they are not parallel. Now, determining whether these two lines are parallel, we need to find their slope. So finding the slope of the first one, we get it in slope-intercept form. So we subtract 5x. And that gives us, so the 5x's over here cancel. So you have y equals -5x minus 6. Okay, so the slope of that line, -5. To determine what the slope of this line is, we need to solve for y, so subtract 5x. So we get cancellation, so we get 3y equals -5x minus 15. And then last thing, divide everything by 3. We want to compare the slope here. -5/3 and -5. Those are not the same. If they're parallel, they have the exact same slope. So no, these are not parallel. So looking at this next set, we want to determine whether they're perpendicular. And same thing, we need to know what the slope is here. So what we're going to do is solve each of these equations for y. So looking at the top one, if I want to solve that for y, I am going to get rid of the 2x. So subtract 2x, subtract 2x. And I'll write over here. So these cancel. So we have -5y equals -2x minus 3. Then divide everything by -5. And here these cancel. Now notice, this right here is going to be the slope. So we have our y equals negative divided negative is a positive, 2/5. And then finally, we have a positive, because we have a negative divided by a negative, 3/5. So 2/5 is the slope. Now we need to determine what the slope of this line is. So subtract our 5x. Here they cancel. We have 2y equals negative 5x plus 6, divide by 2, divide by 2, divide by 2. And the slope of this line, after we get cancellation here, is negative 5/2. So negative 5/2 and negative 2/5. Are those of opposite sign? Yes. Are they reciprocals? Yes. So because these are negative, they're called negative reciprocals of one another, these two lines are perpendicular. Notice, we're not graphing when we're determining whether lines are parallel, perpendicular, or neither. We're just comparing the slopes, and that's what we want to do for these. So we'll move on to this next one. Solving this top one here, we're going to get the y alone, so subtract 2x. Cancellation here, so we get 6y equals 2x minus 3. Divide everything by 6. We get y equals negative 1/3 x minus 1/2. So negative 1/3 is the slope of this. So think about, what would the slope of this have to be for it to be perpendicular? Well, it'd have to be the negative reciprocal. So the opposite of a negative is a positive, and the reciprocal of 1/3 is 3/1. So if the slope of this is positive 3, they are perpendicular. If it's not, well, then they're not perpendicular. So to solve the second equation for y and get it in that slope-intercept form, we want to divide everything by 12. These cancel, so we get y equals negative, we can simplify that to 1/3 x, plus that we could simplify, divide both sides, or divide numerator and denominator by 4, so we have 5/3. Now notice, slope negative 1/3, slope negative 1/3, these are not perpendicular, these are parallel. It asks if they're perpendicular. The answer to that would be no, but we do want to note that they are parallel. Okay. So the last couple we have right here, we're just determining whether these lines are parallel, perpendicular, or neither. And it's really just a lot of algebra to be solving for y. So what we're going to be doing is solving for y in both of these and then comparing these slopes. So here I want to get rid of this 21, so subtract 21, come over here. We have 3y equals 2x minus 21, divide by 3. And we get y equals 2/3 x minus 7. So the slope, 2/3. So this one right here, solving for y, divide everything by 2. And I'm going to write this a little bit differently. Here we get the cancellation, but I'm going to write the x first to get it in that slope-intercept form. So negative, so y equals negative 3/2 x, and then moving the 16 divided by 2 to the back, plus 8. So slopes are 2/3 and negative 3/2. That means these are perpendicular. And there's a symbol for perpendicular. It's an upside-down capital T. That will define that these are perpendicular. But because the slopes are negative reciprocals, perpendicular. So looking at this next one, we want to determine whether they're parallel, perpendicular, or neither. Go ahead and solve for y. In this one, I'm going to move the 21 over. And in fact, you'll notice that this is actually the same one as this right here. So we've already solved that. We know that this first equation is going to have slope y equals 2/3 x minus 7, slope 2/3. So we just need to determine the slope of the second one. So solving for y, divide by 3, divide by 3, divide by 3. So we get cancellation here, y equals 2/3 x plus 8. Now, this has slope 2/3, this has slope 2/3, because the slopes are the same, they're parallel. And just like perpendicular has a symbol, two vertical parallel lines is the symbol for parallel. You're going to write this out, P-A-R-L-L-E-L. They are in fact parallel. Okay, so two more. Let's take a look at this next one. This is in slope-intercept form, so the slope is just 2.1. Okay, Now, you could write that as 21 tenths, like the fraction, since this would mean a rise of 21 and a run of 10, rather than this, which is 2.1, or 2 and 1 tenths, so we can write it as that 21 tenths. So, we're going to look for a slope that's similar to that. Solving this guy for y, we add 63x's. They cancel, so we get 30y equals 63x plus 10. 63. Divide everything by 30. Cancellation there, so we get y equals. Now 60 30ths, we could reduce that. Both of them are divisible by 3, so we could say 21 tenths x plus 1/3. Now, if you did this in your calculator, you get the 2.1. I reduced it to get the 21 tenths. So it looks like the slopes of these two lines are in fact the same, and the y-intercepts are different, so these are parallel. Right. I'm going to put the little two parallel bars there. So, this last one here, y equals 5. Now, y equals 5, anytime we have y equals a number, that is going to be a horizontal line that has a y-intercept of 0, 5. So that's what this line looks like. So this one has a slope m equals 0. That is 0 right there. Solving this, we need to solve for the y, divide both sides by 2. We get y equals 5, which is the same as that. So it's really the same line that's just laying on top of it. Now those lines aren't parallel because two parallel lines never touch and these touch everywhere. So these are not parallel, they're not perpendicular, they are neither. And that's a situation where the lines have the same slope, that is m equals 0, but they have the same y-intercept, so they're the same line, and they're defined not to be parallel. So that was parallel, perpendicular, neither. Remember, we're not really graphing them to determine these things. We're solving them for y or f of x, getting them in the slope-intercept form, and then using that and comparing slopes to determine whether or not things are parallel, perpendicular, or in fact neither. All right, see ya.